Welcome to Termite Machine Works. My name is Keith, and today we're getting ready to reassemble this Jackshaft. Now, before I get started on here, I'd like to make a comment on you guys making comments. I'm glad. I really enjoy all the comments and the feeds, the positive feed, the informative feed that you guys put into my channel. Every once in a while, a little pissing contest will get in there, and you know, I hate to have to hold hands on that kind of a situation there. You know, let's just keep it clean and informative, and really, like my mom said, if you didn't have anything to say, don't say anything at all. All right. With that said, there, let's get going. Now I'm going to go ahead and I got a new piece of paper here and folded it up, and all I'm doing is massaging the outside surface on the shaft here. I'm in search of high spots, anything that's sticking up that might be just a little interference on any of the fits of this metal-to-metal contacts for the taper locks or the QDs and the sheaves and the bearings, taper locks as well. And by rubbing over with the paper there, it actually will highlight any raised area, and then I take a file and then knock that off of there and continue on until I get the whole shaft done. So that's kind of what I'm working on right now. Now I'll bring you in a little closer, and you can see that this one scar that I actually saw underneath this QD bearing or sleeve right here is still pronounced and is still raised up, and we're going to go ahead and we're going to knock that off. So I want to bring you in closer so you can get a look at that. Alright, right there is it's like a score, a scratch, or a knock that somebody knocked in there. Well, at this end here, it raised up the material, and by sanding over there, it kind of like glossed that area. So now we just go ahead and we just take the file and we'll just draw filing across the top just to go ahead and make sure that we knock that off. Now I can see there, but it's still a little hollow on that side right there. Alright, now I know I got that 100%. Alright, now just to double check that, we're going to go ahead. Alright, now it shows no marks there. Alright, so we're just going to finish. Alright, there's another little one right there. So we're just going to continue on over the whole shaft here, make sure that all of those are removed. Alright, we got the rest of the little hides all knocked down, and we wiped down the shaft, and we're all set and finished on the outside here. Now we're ready to start assembling it. Now the first thing I'm going to do is set the key back in here, and we've removed all of the high spots and all of that on here, and we're dropping the key back in its original location. If we flip it around here, it will be in its original location. And you couldn't mess it up. It is match marked with its own wear and color and alignment. Alright, and right there. Alright, it still has a little bit of a curve to it, and but it moves freely, and we're going to slide the sleeves right on over that. Now I'm not putting any never sees or anything else underneath this, because I do not want to take a chance on getting any film of any liquids or anti-seize materials in between the metals. I want metal to metal contact here. Alright, we got this QD all cleaned up ready, one of our QDs anyway, we got it ready, cleaned up, ready to install, but I wanted to go ahead and put these side by side here just for a little conversation here, for chit chat. Alright, there's a couple, they're all the same heights and width configuration as far as the two bushings themselves. Alright, this one here is a solid surface from here to here. This one here has got a relief in between. Now, that's pros and cons on whether the extra surface is good or not. The other difference that I've noticed in the bushings is both of them are grade 5 bolts. And by the way, any of our torque readings or whatever will be gauged by grade 5. Alright, now this is a fully threaded stud or bolt, and this one here has got a straight shank and then a thread in a certain section. You know, there's controversies of which is a stronger bolt. You know, in all reality, the root diameter of your thread is the weakest point of your bolt, and it's just that you have X amount of length of straight shoulder that doesn't have that reduced diameter. Just kind of pointing out a few things. Okay, let's take a look at the two bushings that we pulled out. Alright, opening the new hardware and instructions that I got with the ball door Masca is the name of the manufacturer, and they're located in Canada, by the way. I was reading through on the proper procedures of installing the QD sleeves, the torque, and also they call out how to tighten up the screws and the distance or the gap between this flange and the housing there. Tighten screws evenly and progressively. Never allow the sheave to be drawn in contact with the flange of the bushing. Okay, this should never touch the other side there. The gap should measure from 1/8 to 1/4 of an inch. Alright, CX, that's just a drawing. If extreme screw tightening forces are applied, excessive pressures will create in the hub of the mounted sheave, which may cause it to crack. Okay, well, it didn't crack on installation there because we saw that my brake is fresh and clean, but it did break on the removal. So what I did is I went ahead and we didn't really get into torque and what the actual torque was on the bolts or whatever, or even knowing that factor. What I was paying attention to was the contact of the surface and the surface marks in relationship to each other. Now what I did is I went out to the drum, the sheaves themselves, and the sheave that this was in, from this edge line right here to the mark to the top, was 2 inch. Alright, that is barely, that's like, this is like 2 inch 60 thousandths. Okay, so that was only a 1/16 of an inch off of there. That was over tightened. Now this one here was 800 thousandths, and that's about where it is right there. And this actually had 250. It was a 1/4 inch. So this one was almost 3/16 of an inch on farther than this one here. Alright, and that could have had something to do with the firmness that caused this to be stubborn to come off more so than this. A lot of us thought that it was me heating it, but I didn't create a heat transfer that popped it free. Alright, I heated it up, and then that heat normalized somewhat before this actually came loose. That's why I didn't apply any heat to this one here, because I didn't think that this really was affected by that heat. That was a question in the comments, and I was just relaying my own thoughts on that. So my investigation was how much this was drawn on and how much this was, and I want to really make sure that we don't overdraw on one of these couplings. And then we're going to be in a combination. Now I'm reading, you know, the specs. This is kind of my torque, bolt and torque specs that I have. USA bolt grades, and it gives you 2, 5, 7, and 8. All right. When I was taking the thing apart, I was talking about 8, but I really didn't look in and see the insignia on the bolts that they were 8. I was just talking about torque sequence for a grade 8. These are grade 5s, alright? Now grade 5, 3/4 10 comes in here, and a dry torque would be 260, and an oiled would be 200. that would be general guidelines. Now what I did is I went into this little information chart here that actually is called out for the equipment that we are installing. And they have, this is a style M QD, and 3/4 the size of the bolt, and they're calling out for a torque of 225. But they're also, in their instructions, they're combining that torque with the clearance dimension here. You got to compensate or judge one and the other. So when we're putting this together, we're going to be looking at that measurement in relationship to our torque and what we got going. I also, this doesn't say whether this is a wet or a dry torque. And I'm going to go ahead and I'm going to coat my threads with Never Seas just so that there is no, these were dry and there was no problem getting these out, but I want to make sure the next guy doesn't, and that's my own preference. Okay, I'm not telling you to do that or not to do that. I'm just going to tell you what I am doing. This space is so hard to look down inside there and actually get a gap in there. We're going to do an overall height measurement on our new sleeve and an overall depth on our new sheave, and we will be able to measure the amount of stick out on this side right here to tell us how much gap is on this back side here. Alright, we're going to go ahead and slide this sleeve on this side here. We're going to try it without a wedge in here just to see, and this flange side goes first. And we're putting these on dry. Alright, and it's a little bit rough getting it on there, especially when it gets all the way in there. We're going to go ahead and add a little wedge with just a couple taps. This isn't something extreme. You don't, just a couple thousand is all you need to have in there. Alright, make all the difference in the world. Alright, we'll move the block here. Alright, now we knew we had to push that key down a little bit. Alright, now we got a light and we're going to put this in position here. We're going to use the rawhide mallet. We're looking at our shadow on the shaft, and we're going to verify center of where the set screw was located there. And it is in a slight little difference here, but our shaft is in the same spot. Alright, we went out and we double checked a couple measurements there, and before we put the set screw in here, we double checked our depth and our face of our pulley from one sheave to another sheave, and we also went ahead and measured from here out to our location to the end of the shaft and verified that that is within 1/16 of an inch of where we were before. Alright, now I'm going ahead and open up my Never Seas here, just because this is the first fastener, and I want to make sure that these are removable by somebody else in the future. Okay, and I'm not going to go crazy on these right here because I don't want to lift and distort, but I do know that that cut point will dig into that keyway, and the rest of watching the assembly and the removal and knowing that there was good contact all the way around in here, that set screw, the way they tightened it down, wasn't holding up that section there. If that set screw was like sideways from the split line, it would probably be more detrimental to actually hold your part out from the surface there. But this is one of the things that on marine applications, on split flanges and stuff like that, where you have the set screw opposite of the split line, you want to make sure that you don't tighten those down until the clamp bolts are tight. So this is just something that I noticed, and I don't want to get carried away with it. Alright, now we'll go ahead and we'll get our other one slid on here. We can pull this key out now. Alright, we got this one slid on as well. Now I stare down and this set screw almost lines up with the other dimple, but I'm not judging by that. What I'm judging by is our dimensions and our original location that you can visually see on both sides here of the bearing, or the coupling here. And we'll give this a little cinch. Alright. And we'll release there. And both of these are wiped off. Okay, we're going to prep the sheaves and get those slid on in position. Alright, there's a little tiny bit of overspray in the center area here, so we're taking just a hand polish. We're not going to take any tools. We're just kind of making sure that we got the rough overspray out of there. Alright, we're going to roll it around so we can get a close look at the other side. Okay, we're happy about that. We're going to give it a little wipe here. Alright, now we're going to go ahead, because this got some damage just the way it came to me, and we're going to go ahead and I don't know how to undo these things here. Let's see. That's how we undo those things. Alright, looks pretty good so far on this side here. Just a little bit of scratch paint, not bad. And all the way around looks pretty good. Alright. Let's roll it across the floor here, get it over to the other side. There we go. Alright, now I noticed it has a tag in here and it says warning. Use of lubricant on taper surfaces when mounting sheaves voids all manufacturer warranties. Utilizer blah 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 blah. Alright, we're going to leave that right on there. That's what we were saying when we were taking the thing apart. And anytime that you have a liquid or a paste on a taper lock surface, you create a hydraulic lock. And it'll go up so far, and you can never get rid of 100% of that total thickness of material that you coated it with, and it'll remain in between the two surfaces until the torsion and the RPMs and the working load is applied, and then it's going to start loosening up, so you never really get it tight the way it's supposed to be. And that's why it's important to assemble metal to metal surfaces ding free and lubrication free. Alright, now let's go ahead and yeah, I'm going to pick this up and slide it on. Yeah, right, okay. ahead and give it a rotation here until we know we're lined up. And before we bring it all the way in tight, we're going to make sure that this it's actually pretty close right now. Once you get one started in and you know your hub is aligned, all right, I have it pushed back so it's all gapped so I can make sure that I can make the last effort to blow out anything that's in there. All right, now I'm going to pull it in towards me until it's locked in there. And I'm going to go ahead and I'm going to jiggle it a little bit on this end here, just to make sure. Okay. Now the rest of the bolts should line up. Now we're going to put a couple in just to make sure that they are screwing in. And once we know that they are going to start, I'm going to put some never sees on the threads. Okay, there's two that are starting, and this one bolt here has this little counterweight right here is in the way. So we're going to unbolt the counterweight and put the bolt in and then put the counterweight back on so that the pulley stays balanced the way they intended it to. And I believe that was just a 7/16 there. Yep. They put some kind of Loctite or something on that. Alright, now we should be able to get these in. Alright, so we're going to go ahead and paint some never sees onto these bolts now, so we make sure that they're not going to freeze up on the next person. Okay, just even with the hand ratchet until we got some tension on it so we know it's not going to be moving around. We're going to go ahead and we're going to get that side assembled on here now. We're going to verify our dimension in the middle, which it may change just slightly because one of these was over tightened by 1/8 of an inch of travel, so this might be a little bit larger in here than the 7/16 original gap there. Boy, did I almost get that perfect. Alright, let's see if we can. I think I got it started.